Stoich 6. Question 2. We are given the grams of hydrogen, oxygen gases, and they react explosively to form water. We've got a balanced equation. It wants us to set up a BCA table to find out the limiting and excess reactants. It wants us to calculate the theoretical yield of water in grams, so we'll be doing some converting, and the mass of excess reactant remaining, the mass. And so again, some more conversions going on. So we're given the mass of the reactant to start with. We'd convert that to the moles of reactants, then convert using molar ratios to the moles of the product, which is water. And then once we know the moles of the product, we can convert that to the mass of the product using molar mass. What part of the Stoich roadmap would we use? Well, we're going to go from mass of reactant to moles of reactant to moles of product to mass of product. So using molar mass twice, and we're going to be using a molar ratio, conversion factors. Let's take that out of the way, put the question back in. Okay, there is the BCA table. We've got hydrogen, oxygen, and the product water. What is the limiting reactant? I always think it's the quickest way to do this is before I go on, you can never use mass to determine the limiting reactant. You've got to convert to moles. Okay, so we must convert to moles first. So let's do that, and we'll use the molar mass to do it. We've got 10 grams of hydrogen, and the molar mass of hydrogen is 2.016 grams per mole. Got it to 4 sig figs because we're given 4 sig figs there. Conversion factor 1 divided by 2.016. The moles go on top. That's what we're trying to find. Stick it in there and do the maths. I've got 2.9505 moles of hydrogen. Let's see, for the oxygen, we've also got 10 grams. The molar mass of oxygen is 32.00. The conversion factor we shall use, 1 mole over 32 grams. Remember that moles will go on the top. That's what we're trying to find. And it gives us 0.3125 moles. I'm going to put that in there. So this is what we are starting with. 4.95 moles of hydrogen and 0.31 of oxygen. And there's no product to begin with, so we'll stick that in 2. To find the limiting reactant, we find which has a lower mole to coefficient ratio. Hydrogen, we've got roughly 5 grams, and I've just simplified it here to make the math easier. We've got 5 moles divided by 2, the coefficient gives us 2.5. For oxygen, we've got about 0.31, and we can divide it by the coefficient, which is 1, give us 0.31. And we can see oxygen has a smaller ratio, and so is the limiting reactant. Remember, all of the limiting reactant is used during the reaction, and so all 0.3125 moles of oxygen reacts, and so we would have no oxygen remaining at the end. To calculate the mass of H2O produced, we need to use mole ratio first to find the moles of water, and then we'd use molar mass to calculate the mass of H2O. So let's find the moles of H2 and H2O first. So 0.3125 moles of oxygen reacted. We know that 1 mole of oxygen reacts with 2 moles of H2. That's a conversion factor of 2 over 1. And hydrogen goes on the top. That's what we're trying to find here, the moles of hydrogen. So we get 0.625 moles of hydrogen will react. And 2 moles of hydrogen, we can see in the reaction, the 2 moles of hydrogen gives us 2 moles of water. So the ratio is 1 to 1. If we had 4 moles of hydrogen, we'd produce 4 moles of water. If we had 10,000 moles of hydrogen, we'd produce 10,000 moles of water. But we in fact have 0.625 moles, and so we are going to get 0.625 moles of water. They are the same, they are equivalent. So we're going to get 0.625 moles of water produced. Now let's have a look. We start with 4.95 moles of hydrogen and use 0.625. So if we just take it away, we know we're going to get 4.325 moles at the end. and we have produced 0.625 moles of water. So yield of water in grams. We'll have to use molar mass of water for the conversion factor, 18 grams over 1 mole. And that gives us 11.16 grams of water. And we've got 4 significant figures, and so that's what we're going to use in the answer. To calculate the mass of hydrogen remaining, the excess hydrogen, we'd use molar mass of hydrogen. Again, I'm going to use 4 sig figs because that's what we're given. The conversion factor would be 2.016 of 1 mole. Grams go on the top because that's what we're trying to find. And we get 8.719 grams of hydrogen remaining.